In today's video, we're going to be solving linear systems graphically. So what a system is two equations or more equations, but the problems that we're going to be doing today are going to just have two. So what we're going to do is have two equations, and we're going to see if they intersect at any point on the graph, and that point would be considered their solution. Now, if they don't intersect, they would have no solution. But for pretty much the most part, most of these problems that we're going to be given today, they're going to intersect at a point. And we're going to use the skills we know on how to graph a line. So remember, how do we graph a line? We have y equals mx plus b. The b is where you start on the y-axis, and the m is the rise over run. So if we take a look at this first problem, we have the first system, right? So we start at 6 on the y-axis with this line, and we go up 1 to the right 3. So you start at 6, go up 1 to the right 3, and click. Okay. This one, you start at -6, and you go down 5 to the right 3. -6. And 1, 2, so I can't go all the way down 5 to the right 3. So I have to go up 5 and to the left 3. And what you'll notice is that they intersect at this point right here. Okay, we have to figure out where from the origin is that point. So that point, the coordinates of that point is -6, +4. So type in your answer. -6, comma 4. They have to be in parentheses or else they're not coordinates. Yes. Okay, let's look at another one. All right, this one, you start at 4. Now, before the x, you don't see anything. There's an invisible 1. That means the slope is up 1 to the right 1. So you start at 4, go up 1 to the right 1. There's your line right there. This one, you start at -8, and you go down 1 to the right 2. -8, down 1 to the right 2. See where they intersect at? From the origin, it's left 8, down 4. So it's -8, -4. Okay. There we go. And what's nice, when you put in your answer, they show the lines outlined for you and everything. Awesome demonstration. Let's look at another one. Okay, this one starts at +2, and it goes, again, up 1 to the right 1. This one starts at -2 and goes down 1 to the right 3. Down 1 to the right 3. And they intersect at -3, -1. And always important to put those parentheses in, or else it's not considered a coordinate. It's considered a solution set, as opposed to one solution. Let's take a look at it. Maybe get another type of problem here that will look different. I'm trying to see, because sometimes you might get a scenario where you graph two lines and they are parallel. So if you ever get a chance where you have two lines that are parallel, that means they would have no solution. Or if you had one line on top of another, that's another example where they would have, they would have infinite solutions. I'm trying to look here. Let's do this one though. Okay, so we start at 2. This is -x, -1. So you go down 1 to the right 1. This one is at -4, and you go up 2 to the right 1. and they intersect that on the actual x-axis, which is 2, 0. All right, so remember, whenever there's a number out in front, it's always over 1 if it's not a fraction. 2, 0. I don't think they're going to ask us questions where they have no solutions or infinite solutions. So an example of I'll just show this on the graph of something that has no solutions would be something like this. All right, you have two parallel lines that never intersect. These would have no solution. Okay. Now, if you had something with an infinite solution, you would have one line on top of another line. Well, it doesn't let me do it, but you would have one line lying on top of another line. That means they intersect at infinite spots. All right. So that's it for today's video. Again, all of this is just doing this on the program. No really work required on paper. And so if you have questions, let me know, but good luck.